A traffic sign with a mass of 5 kilograms is suspended above the street as shown. Determine the forces of tension on each of the wires. So here's our diagram, and so to start we have that the force of gravity is pulling down with a force of 9.8 meters per second times 5 kilograms, which is 49 newtons. So that's our force of gravity. And remember, that's balanced out by the force of tension on the ropes. So that's the big force of tension. Now, I'll remind you that the shorter rope is going to have more tension than the long rope. And so my force diagram doesn't match the picture diagram. So I need the forces of tension to add to this tall one. So I'm picturing this is here and here. So there's, I'll call that tension 1. I'll call this tension 2. And I'll match it up on this side. So there's tension 1 again, and tension 2 would be here. So I have two angles, the 45 and the 60, which you can kind of see around here and here. So if I draw an F pattern here, I can see that this angle is going to be 60 degrees. And on the other side, how do I show that? It's kind of hard to see the Z pattern, but here to here to here would be a Z pattern, and then there'd be an F pattern that brings that angle up here. So the 45 actually lies up here. So the total angle in the corner is 60 plus 45, so 105. And then we can see a right angle triangle right here, or right here, sorry, oops. Let's get that shown. Right here we see a right angle triangle. So the 60 degrees has to add with this one to make 90. So my bottom corner is going to be 30 degrees. And then similarly up here, I have a right angle triangle. So if this is 45, then the top corner is going to be 45 also, because 45 and 45 add to 90. And so I have everything I need to solve for the forces of tension. So I'm going to bring this diagram to the side here. Just pulling out the one side. So this is my tension 2, this is my tension 1, and this is 49 newtons. That's my full force of tension. And this angle is 105. We have 30 and 45. And so I can see a pogo. I have these two that are opposite each other, so I'm going to use the sine law to solve for the magnitude of tension on each of them. So I'll just start one of them. The magnitude of T1 over the sine of 45 is going to be equal to 49 over the sine of 105. And then I'll solve for T1. I think you can do the rest.